Hi everyone, I hope you're well. I will apologize for the lack of production values of this video, but I hope you find it useful. This is a review for Lab 8 of the function or of writing a function working with the frequency counts that we have. So let's start off reviewing the program itself. So as with our other programs that use the NSFG data, first thing we do is import NSFG. We'll skip over the function definition at the moment. And then we use getData in the NSFG module to get the data. Then the program creates two empty dictionaries, as you can see here, and then enters a loop where we process each record in data, grab its pregnancy length field, and then looking at the birth order field, if it's a first birth, we count that pregnancy, we increase the count for that pregnancy length by 1. If the birth is an other live birth, right, so second, third, fourth, etc. births, then we increase the count of the number of pregnancies of that length by 1. Okay, so this loop is doing all the work with the NSFG records. When the functions, in this case prob and range, that you're writing are used, so what's passed in are the dictionaries, the frequency counts. So that's what to keep in mind when you complete the prob and range function. You're just working with frequency counts. So let's write an example similar to what you'll be working on, but I think different enough that you'll get some practice writing the function on your own. So this is going to be a function that compute the probability of a birth during a particular week. Okay, so how do we start a function? Use the DEF keyword, and then we name the function. So let's just name this prob. Okay, and then in a parenthesized list, what are the inputs functions? Here data will be a dictionary of frequency counts. Week is the week number for this probability that we're computing, right? The probability that a baby is born during a particular week. Don't forget the colon at the end. Okay. Excuse me. So we're doing probabilities. Remember that a probability is a ratio of two sums. Okay, so we have a numerator and a denominator. Remember that the sums always start at 0. Let's do the sum for the denominator first. So the denominator is going to be the total number of births. Okay, so we need to loop through the data in the dictionary Okay, so remember, this is data is a dictionary, not the NSFG data. We want to pull out the pairs of week numbers and the number of births during that week. This is how we do that. Don't forget these parentheses here. Item here will be the week number. Count will be the number of births during that week. Okay, so in this case, we want to count all of the births. So we write a line of code like this to do that. Oop. Okay, think for a moment. What goes here? Is it item or is it count? It's count. That's the number of babies born during this week. Okay. That gives us our denominator. Let's move on to the numerator now. Okay. We start the loop the same way. This time we're doing conditional counting with these frequency counts, right? Because in the numerator, we only want the number of births in week WK. So remember, with conditional summation or counting, we use the if statement. So if item, remember item is the number of weeks, if it equals week, then add the number of births during that week to the numerator. Okay. Pay close attention to how the indentation. So what we want the function to output is its probability. The numerator divided by the denominator. And we do that like so. Okay, so this completes the function. There are three big pieces in here: initializing variables, gathering data, and then computing the function's output and outputting it. Let's use this function now. Okay. I'm going to delete these lines. All right. We'll use the function in a print. Let's do probability of first birth in week 39. All right, there's the label for it. Now let's use up the function we just wrote. Yeah. Notice how the parentheses line up. Print has a pair of parentheses. Prob has a pair of parentheses. Okay, the label here and the use of the function are the inputs to print, and we put the inputs to prob between its pair of parentheses. All right, so this is, we want first births. All right, so if you want to pause this, think for a second what the first input will be. It'll be first counts. And then the second input to the function is 39, because we want the number of births with the probability of a birth in week 39. Okay, let's see if this runs. I like to test things as soon as I can. Yep, indentation error. All right. What did I do wrong? Ah, I still have this function in here. Let's delete that too. Okay. All right, it's running. All right, so the probability of first birth in week 39 is 0.479. Okay. Let's use the function another time. Print, what should we do this time? Probability of other birth in week 42. Let's pick a random number. You know that's not random for me. Okay. Now, again, we use prob. Now we want other counts. Week 42. Okay, let's run that. Okay, 0.025. All right, so one last thing. Since we're getting the number of births in the numerator for just 1 week, we don't actually need a loop to do that. Or we can use a get function on the dictionary in order to get the number of births for just 1 week. Okay, so let's revise the function slightly to make use of that. You don't have to do it this way. Lab 9, we'll be doing something like this. You can use get, or you can use a loop, whatever you're most comfortable with. Okay, I gotta fix my indentation. So the numerator is data.get. Okay, think for a second. What I want to type next, what would you type? It's week. And what do I want for the default value? Remember, there weren't always any births in a particular week. That's why we wouldn't use the other form of with the square brackets. Okay, the default is 0. Let's see if we get the same results. We did. Good. All right, so that's a review of functions and some more detail on how we're using these frequency counts to compute probabilities. I hope you found this useful. Take care.